Hi everyone, welcome back to the channel. Today, we're diving into one of the most crucial aspects of transportation, infrastructure, highway development, and planning, especially when it intersects with railroad engineering. We'll explore how highways are designed and integrated with railroads, and what factors engineers consider to ensure that both systems work smoothly together. Let's get into it. Before we get into how modern highways are built today, let's take a quick journey through history to see how road construction has evolved over time. The earliest roads were simple dirt paths. In ancient Mesopotamia, around 3000 BCE, the Sumerians used basic roads for trade and military purposes. But things really began to take off when the Romans came into the picture. Between 500 BCE, they built an extensive network of roads, around 250,000 miles of them. Roman roads were engineering marvels. They weren't just dirt paths. They were designed with multiple layers, including a sturdy stone foundation and drainage systems, which made them durable and long-lasting. The Via Appia, or Appian Way, is one of the most famous examples, and it's still standing today. Today, we have highways designed not just for vehicles but for the future. Smart roads, with integrated technologies to manage traffic flow and even charge electric vehicles, are the next frontier in road development. Now that we've seen the history of road construction, let's break down how roads are classified. Roads can be grouped based on their function, location, and design. Let us take a look at the most common types of roads you'll find in any transportation network. First classification is the type of road. It's classified depending on whether they can be used all throughout the year. We have the all-weather roads. It is a road that is trafficable in all weather conditions. Typically, this means a road that is constructed in such a way that excessive rain does not cause it to be flooded or sodden, to such an extent that vehicles traveling over it are likely to become bogged in fair weather road. On these roads, the traffic may be interrupted during monsoon season at causeways, where streams may overflow across the roads. Second, it is classified based on the carriage or road pavement type. We have paved road. It is provided with a hard pavement course, which should be at least a water-bound macadam layer, and also the unpaved roads, where it is just an earth roads or gravel roads. Third, we have based on the type of pavement surfacing provided. We have surface roads wherein it provided with bituminous or cement concrete surfacing, and also unsurfaced roads which are not provided with bituminous or cement concrete surfacing. In the Philippines, we also have a classification of roads set by the Department of Public Works and Highways. The DPWH is responsible for planning, designing, constructing, and maintaining infrastructure such as road networks, bridges, and a lot more, gearing towards sustainable growth and development of the country. First, national primary roads. They are further classified into the north-south backbone, east-west, lateral, and other roads of strategic importance. The north-south backbone refers to the Pan-Philippine Highway, which runs from Loag in the northernmost parts of Luzon to Zamboanga City in western Mindanao, interconnecting the country's major islands. Second, national secondary roads. The national secondary roads are roads that complement the primary roads and provide access to other major population centers. They directly link smaller cities and provincial capitals, airports, seaports, and tourist centers to the primary roads. Third, national tertiary roads. The third classification was introduced in 2014, known as national tertiary roads. They include other existing roads administered by the DPWH which perform a local function. Fourth, under local roads, we have provincial roads. Roads that connect cities and municipalities without using national roads, and roads connecting major provincial infrastructure. While they're not as large as national roads, provincial roads are still important for regional trade and travel. They may be 2 lanes, with fewer access points, and may require some upgrades as traffic grows. Fifth, under local roads, we have municipal and city roads. These are the roads maintained by city or municipal governments. Sixth in the list is the barangay roads. Rural roads located either outside of the urban area of a city or outside industrial, commercial, or residential subdivisions, which act as feeder or farm-to-market roads, and which are not otherwise classified as national, provincial, city, or municipal roads. Lastly, we have the expressway. It is a high-speed divided highway for through traffic with access partially or fully controlled. Now that we've covered the classification of roads, let us talk about road patterns. Way. Roads are laid out and organized within a region or city. The design of road patterns affects traffic flow, accessibility, and the overall structure of a community. There are a few common road patterns you'll find in cities and rural areas. A road pattern is a format for constructing road networks that link different locations. The primary goal of road patterns is to improve accessibility by linking major thoroughfares and other key locations within a community. The grid pattern is one of the most common and simplest road layouts, especially in older cities or planned urban areas. In this pattern, roads run parallel and perpendicular to each other, forming a grid-like structure. In urban planning, streets are laid out in a grid-like pattern to form rectangular blocks. Residential, commercial, and industrial blocks are common. This simple, regular design is easy to navigate and develop. This pattern forms a grid of streets intersecting grid, making travel faster and more direct. Rectangular blocks simplify urban development. Next, we have the radial pattern. This design is centered around a central point, like a city center, and roads radiate outward in spokes, similar to a wheel. Radial road patterns are often used in cities that developed around a central hub, like a government building or a market square. The main advantage is that all roads lead to a central point, making it easier to access the heart of the city. However, the challenge is that traffic congestion can occur at the center, as all roads converge in one spot. While most cities use grid, radial, or organic road patterns, there's also the hexagonal road pattern, which is a unique and efficient design used in some modern urban planning projects in the hexagonal pattern. Roads are arranged in a series of interconnected hexagons, rather than the traditional squares of a grid system. Think of it as a beehive structure, where streets form six-sided shapes that interconnect at every corner. Next, let's take a look at the linear road pattern, a layout where roads follow a straight line, usually connecting two or more significant locations. This pattern is often seen in areas where roads are designed to link major points of interest, such as towns, highways, or other hubs. To sum up, road patterns are designed to fit the specific needs of a city or region, whether it's the structured grid, the hub-and-spoke radial system, or the more flexible organic layout. Each pattern plays a key role in how a city's transportation system functions. Before any road or highway is built, one critical step lays the foundation for the entire project. The planning survey. This is where engineers and planners gather crucial data to ensure the road is designed and constructed efficiently and effectively. A planning survey is a detailed study conducted before the design phase begins. It involves collecting, analyzing, and interpreting data about the area where the road will be constructed. The goal is to understand the geographical, environmental, and social factors that will influence the project. During a planning survey, engineers focus on several key aspects, including topography. This involves mapping the physical features of the land, such as hills, valleys, rivers, and existing structures. A topographical survey helps determine the most suitable alignment for the road. Traffic surveys. Traffic volume, types of vehicles, and peak travel times are studied to estimate the demand for the road and design it to handle future growth. Soil investigation. The soil's properties are analyzed to ensure the ground can support the road's weight and structure. This data is crucial for deciding what kind of foundation the road will need. Drainage patterns. Understanding natural water flow is essential to design proper drainage systems, preventing flooding and erosion that could damage the road. Land use and environmental impact. The survey also assesses nearby land use such as residential, commercial, or agricultural areas considers how the road will impact the environment and local communities. Once surveys are completed, the next important step in road planning is determining the highway alignment. This refers to the positioning or layout of the highway on the ground, both horizontally and vertically. A well-planned alignment is crucial for ensuring the highway is safe, efficient, and cost-effective. The requirements of an ideal alignment are the following. Direct. The aligned route between endpoints should be as direct as possible and result in the minimum possible length under the circumstances. Second, easy. The alignment should be such that it is easy to construct, maintain, and operate the highway. The curves and gradients should be easy. Next, safe. Safety for the road user should be the primary consideration. The stability of natural slopes and man-made slopes for embankments and cuttings should be ensured to prevent possible accidents. Next, economical. The overall cost of construction and maintenance of the road, as also the operation cost of the vehicles, should be as low as possible. Lastly, special considerations. Depending upon the purpose of the highway and the characteristics of the terrain, special considerations may be needed, as in the case of hill roads or GOT roads. Thank you for joining us on this journey into the fascinating world of highway development and planning. Whether you're a student, an engineer, or simply curious about how our roads come to life, we hope you've gained valuable insights into the art and science behind highway engineering. Remember, every road starts with a vision, and every mile is built with purpose. Until next time, safe travels, and keep exploring.